Deep, this is an Eclipse editor, right? Now,
Yes, sir.
did I write any program here? Java, these are not Java code. This is simple text.
Yes, sir.
It doesn't have nothing to do with Java, just simple text. Okay, that's why I say that it is just an editor, like a VI editor, like any editor, Note++, Notepad, and whatever. So this is one of the editors, but yes, it has so many features that will help you to compile, run Java or any other code. Fine. Let's start today's topic. Today, we were actually in the middle of this exceptions, handling exceptions. We have completed exception handling, try, catch. Finally, we have known what is try, what is catch, and what is finally, why we need finally. But if we have a try, we can have catch. We have to have a catch. But suppose we do not have a catch, we can have a try. At least you need to complete that try with the finally. So a try cannot be orphaned. You cannot say, I will use only the try block. I will not have either catch or finally. You cannot do that. And we have seen that how we can specify multiple catch in one block. Okay, like you have only one catch, but you are catching up with many of the exceptions, with multiple exceptions separated by pipe. We will start today with a checked exception. Checked exception. We have seen unchecked exceptions. Unchecked exception, that is the exceptions which has happened in the runtime. Are you getting me? That's something which you, like the division by zero error. You have not actually used that within the try catch block. But that compiler will also not help you to find out what will happen in the runtime. It will fail. It will give an unchecked exception. So you can handle those unchecked exception, but you can also handle the checked exception. We will see that. Okay. Let us see what is a checked exception. Checked means compiler is aware of the error and warns you during the compilation. This is a very nice, beautiful feature of Java. See, again, Deep, this is a Java code. Okay, I have written it only here, but at the same time, I have given the comments as well. These comments as well. These comments are not Java code. This is just to document your program or whatever you are commenting it. You are putting some comments so that the user using this particular program will be able to understand what you have written here. So here I am trying to write a program in Java. I will see that whether I can handle the exception which has been thrown by the compiler. That means the compiler is aware while you are writing this. Compiler, during the time of compilation, it will know. And one beauty of it is that you see, whenever I will be writing a code, the compiler will, it is sort of a, it will keep on compiling as you go, as you write the code. It doesn't wait for you to compile. Okay, it will not wait for you to compile, like unlike in other editors or other thing, that you have to compile it separately, then you will run it. But here, as you keep on typing, you will get an error if there is an error. Let's say, so the compiler knows where the error is. Compiler is very much aware of this sort of resources like buffered reader, which is coming from Java IO package, buffered reader. These are IO exceptions. Also, input reader is one of the another very costly resource. What is happening is, suppose you are writing something and you are not, you are using this buffered reader, okay? Buffered reader. And buffered reader is an IO. If any exception happens, that means you are opening it you are closing it, you are using it, you are accepting something from the input. So all these are done through the buffered reader. Now, if there is some error during that, there can be, it can be handled two ways. While you are writing the program, the compiler finds that there is an error. There is a possibility of an error. Whereas whenever you are not getting any compilation error, but you have run it, and then there is, through the input, you are expected to input a numeric value. But instead of numeric value, you have put in some alphanumeric value as well. So that is a runtime error. And that is called an unchecked exception if you have not used the catch block. That means you have not handled the exception. And that is caught by runtime. When you are running the program, it has been caught. But that is called a runtime exception. But while writing your code, if you get some error by the compiler, then you know that this is a checked exception. That is, compiler has checked it. So throws exception in the main function resolves the issue. I suppose this throws is one of the clauses, and you say throws exception. What is happening here is I have not given this with the main function. I have remarked it, commented it out. So that means there is no throws exception. I have used a buffered reader, which is a resource of Java. Now, in the finally, I am trying to close it. This is a handle. This is the BR is the pointer or a handle. You have opened, or you opened the buffered reader. Buffered reader is again a class. So that is a constructor you are using it. Like this is a class. You have created an object BR, but you have just initialized it. You have not yet created. Now this will be created once you say the constructor of buffered reader, and you are giving an argument. What is the function of the buffer reader? It is trying to get an input from the system.in is the terminal, the keyboard. You are typing in something. Okay. What I am typing in? I am typing in a number. So I am using this buffer reader, which will accept the input from the terminal, from the keyboard, and through input stream reader. This is again a class. So see, I have initiated. So this object is created out of buffer reader, and buffer reader has used another class called input stream reader. So both of them, these are input output resources of Java, IO resources. So there could be a problem. There could be a problem, like while you are opening the resource or while you are closing the resource. So unknowingly, finally, we have learned that in the finally block, we always, what you do in the finally block, you always try to close anything. You do not try to close within the try or catch. Never do that. We have already learned that. So always in the finally block, you close this. You close the resource. BR is the open resource, you close it, fine. But by doing it, you are wondering why I'm getting an error. You go here. You see unhandled exception by type IO exception. That means the compiler knows that BR is a resource. BR is a resource. When I'm trying to close it, maybe somehow this was opened, fine, there was no issue. But while I'm trying to close it, there could be some error. But you are already in the finally block. There you cannot use a try again. You cannot enclose this operation with a try block. Okay. You cannot do this. And you say catch. Okay. You can do that, but then then how will you close the resource? My question is, you are catching the exception, fine. But finally, your resource is not closed because this resource has got a encountered an error. And you thought maybe it's an IO exception, but it could be some. There could be so many exceptions. How will you know which exception it has handled at that runtime? So what compiler says that, see, dear programmer, you do not, I am giving you a warning. I am giving you a warning. What is the warning? That you are trying to close this within the resource, Java resource or IO resource within the finally block. Fine. But what happens if there is some error? I am not being able to close it. For some whatever, there can be hundreds of issues. You have successfully opened it, but while you are trying to close it, something goes wrong in the memory. Okay. So how do you handle? You do not try to handle it yourself. It is saying that you do not try to handle it yourself, because if you try to handle it, there can be 100 errors and you are not going to catch 100 of those exceptions. It is not possible in a code to handle all the exceptions. So leave it on me. So therefore it gives an error. I mean, there is a compiler error. Yeah, there is an error. So there should not be any bracket like this. Because, see, always you try to do like this. Now I'm fine. See, the compiler error has come back. Unhandled exception type IO exception. Why? Because the compiler is complaining while you have written this code, it is immediately giving an error. This is called the checked exception. Check, not unchecked. Yeah. It is saying that, my dear, you cannot, if you want to do it, so be sure you leave it on me. So leave it on me, you open up and you give it to me. I will handle that exception. Is it clear? Immediately when you say with the main method that throws exception, that means to overcome the checked exception by the compiler. In this case, there is an IO exception. You are trying to handle an IO exception. You do not know. So you better leave it on the compiler. So these are called checked exceptions. See, immediately once you had given this throws exception, what happened here? Your error has gone. There is no error now. That is called a checked exception. And you will ask me, sir, if I do not want to close it. Okay, you can always choose to not close the open resources, but your code will not pass the test. That means there would be somebody, the code checker, when you are working in a corporate organization, if you have opened something, whether it's a file or a buffered reader or an input reader, in-stream reader, if you have opened something, you must close it, and you must close it under finally. Since you have not closed it, your program, your code will fail. It will not go to the testing team. Somebody in between will halt your code to go to the testing team because your code is not correct. You have misused the memory. You will be going to misuse because you have kept in the memory an object or a resource which is kept open. It will kept open means it will occupy the memory space. You cannot do that. Memory is a very costly resource. Okay. So what you do, you have to do this. But at the same time, you cannot handle this error. If there is an error, you cannot handle because you are already in the finally block. So leave it on the compiler. So give this particular exception. This is very important interview question. What is the difference between throws exception and the catch exception? Yeah, of course. Whenever you say throws exception, you are actually, the compiler is diverting you to this catch exception. But you will say, sir, if I do not have an exception like catch, a catch exception, okay, will it not work? I'm not getting an error. It will still work. It will still work. But here, in this case, the exception will be something like it is coming from the exception stack trace. It can be a lengthy message. Your message, when you are handling yourself, you will give some customized like this one. This one is a customized error message. It is not coming from the system because you are handling the message. So always try to throw the exception, yes, because you do not know what exception is going to be there. So, and this exception is the mother exception. This is the super exception. So always try to customize your output, your message, error message. If this thing happens, that IU exception happens, whether you are opening it or closing it 2 times, either you are opening it or closing the resource, an exception can happen. So that's what you are throwing, an exception. Is it clear how to handle the checked exception? So if you are clear, then we have covered this one. Now, we have also covered this one, resources. The resources are buffer reader, input stream reader, are all resources of Java IO package. These resources should be closed after usage. You cannot leave it open. Leaving the resources open can consume huge memory, and the program can be less resource efficient and hence weak in performance. So many problems. Finally, the resources must be closed in the finally block rather in the try catch block. Never try to close any resources in the try or catch block. A try block can be done without the catch block, but at least you need to have a finally block. So as I said, you cannot have an orphan try block. A try block should have either a catch block or a finally block, or both. And the last, we will learn try with resources. That is very important question for an interview. You see, if there are 5 questions in an interview, you can understand, you can be sure that the interviewer will at least have 2 questions from exceptions. Okay. So almost like 40 to 45% of the questions will be from exceptions. And one of the question definitely will be try with resources. We will learn that. But let us see which one. We will try to understand this. There can be an error, there may not be an error, but you cannot leave it on assumption that there will be no error. No programmer in this world can say that whatever code I write, that will be exception free. No. Even if you think so, and even actually if it happens like that, even then also your program will not pass that code checker. Like if you have not used the try catch block with the buffer reader, your program will fail. Not runtime, but somebody will not allow, some person who is the code checker will review your code and will fail it. Okay. Now, what is this program like? I am trying to enter a number. I am asking you to enter a number. Fine. I am opening, not opening. I have still not opened it. I have just initialized an object, but right now it is not an object. It is just a variable and initialized with a null value. Fine. I can do that. I am within the, because then I am making this as a global variable. I'm saying try, Why I need to make it global variable? Because in the finally block, I have to close it. If I have initialized here, I have initialized here, BR, buffer reader, BR equal to null, then what would happen? Anybody guess? This is a try block and I have initialized within the try block, the BR. So whenever you exit the block, your BR will lose its scope. The scope is lost. Therefore, you will not be able to use. Okay, let me show you. Okay, now I have made BR a local to this scope, this try scope. Can you see immediately this has become BR cannot be resolved? It doesn't find that variable or the object. It is not finding it at all, or the handle or the pointer, whatever it is. It is not finding that object at all because it has lost the scope. It has come out of this try block. So always remember, these are the various programming things that you need to know. You must make it a global variable. So once you do that, now see, it is under the main method. So it's fine, it's global. So here you have no error. Okay. So I am using a try block because I am not very sure whether I can open it without any error. So always not take any chances. You say buffered, new buffered reader, BR equal to new buffered reader. You are creating an object, BR, through the input stream. That means you are trying to input something from the keyboard. You have to have some like scanf or something like where you are going to store your input. So that is the storage. That is the resource. Now you say whatever you input from your terminal, from your keyboard, is it an integer or a string? Like you have typed in, you have entered a number 1, 2, 3. Will that number be a number actually? Do you understand my question? What I'm saying is, you have entered a number. You have typed 1, 2, 3. Now to the computer, to the system, to the program, what is that number like? Is it actually a number 1, 2, 3, 123, or it is 1, 2, 3 string?
Actually, G, I think 0 to 1 to 3, 0. Because sir, int n is equal to 0, you put means there is no counting, I think, sir.
No. That is I have initialized n. N is an integer, fine. But I have input a number 1, 2, 3 from in, which is a input stream reader. Whenever you say input stream reader, anything, any system, whether you are writing in Python or you are writing in Java or C or C++, anything you take it from your keyboard, you entered something. Like in the form, you filled up so many forms on the web. You have put in your age. Age is 18 years. Now that 18 is actually not an 18.
Yes,
That 18 is
yes.
it's a string. It's a
Yes,
string.
we have to
Always.
convert it with integer.
So the next action that you need to know once you have taken an input from your terminal is that you have to convert that into an integer.
Yes, we have to encapsulate.
Yeah, because your purpose is to get a number, and you might be doing some arithmetic with that number, or may not. But anything you must take it as a. So what you do, you are using that BR object, and BR object will have a resource. That resource BR is having one method called read line, because you want to read it. No? Read. So many read functions. One is read line. What is read line? Reads a line of text. A line is considered to be terminated by any one of a line feed. That means that line will not be completed unless you press enter. That's why it's read line. So unless you press enter, this BR will keep your mouse or your cursor over there in the same line. So once you press enter, that gets converted into an integer and it's stored in N. So this is the entire atomic process. Okay, you understand, no? So this read line is taking your input through the system.in, because that system.in has been captured with the BR. So BR now knows that I can take an input from the input terminal, the keyboard, but I have to wait for the submit button from the keyboard. Till then, I do not get a new line character. I will not be able to stop the reading. I will keep on reading. And once I get a new line character, I will convert that first into an integer with the parsing function, and I will store it in N. N is an integer. Clear? And now you are trying to print out that here's the output N. Fine. I will never do this within the try block. I will never try to close, because I said you always try to do it with the finally block. And if you want to do it something with the IO activity on the resource, you must use this. We have discussed that. Now, I
Sir,
know
if
there.
we don't use the finally block, then it will also work, I guess. If we don't use the finally block,
Yeah,
if we
but
remove the finally block, then it will also work, I guess.
it will work. See, your code
No,
will
no,
not.
no. Just br.close. I'm just saying the keyword finally and those brackets. If we remove this and we
Suppose
just write
what
br.close.
here I have closed. Okay, I have not commented out.
Yes.
Then I have opening this.
No, no, sir. Not in the try block. I am saying this globally.
Yes,
Close
yes.
globally.
Yeah, that means what you are trying to do, that is what I told you, that you have opened it because you
Yes.
wanted to take the input terminal, but you have not closed the resource. Nowhere
Yes.
you have closed. So your program will not pass.
Yes. And if we try to close here, after the catch block, if you want
That
to
is
close
after
here.
the clash block means what? Here, within the
No,
catch.
sir, no, not here. After the second bracket. Close after the closing bracket.
Oh, so there is no finally, and there is after the
Yes,
catch
yes,
means
yes.
here.
Yes, sir.
br.close. Okay.
Yes, sir.
br.close.
It will also work.
Fine. So you are basically like you have opened it, buffer reader BR. Similarly, you are trying to close it because it is, after all, it has to be in the main method. You are in the main
Yes,
method,
sir.
fine. But
Yes.
do you think that it will never fail? That's why, that is the reason you are enclosing within the finally block and using this throws.
Okay, sir.
Here also, throws will get an error. I mean, this BR you cannot close. So you will be handling. But if it encounters any error and there was some code after this closing as well, there could be. What will happen at this point, the program will terminate. Even if you
Yes,
have
sir.
used,
Yes, sir. After that, BR will not work for this.
after that
program.
BR the following lines will not work.
Yes.
You might have some other code that will not
Yes,
work
sir.
at all.
Yes,
Because
sir. Yes.
at this point, the compiler will, the runtime engine will see there is a problem. I'm not being able to close. There is an IO exception, and it will give from the E stack trace, that the stack trace, error stack trace, it will bring up a big error message, and it will quit. It will exit the program.
Okay, sir.
Why
Okay,
you
sir.
catch the exception? Because you wanted to continue your execution of the code. You give a very nice message, because the message that will be thrown here from the from the stack trace, it can be awe-inspiring. That means the user suddenly gets a lot of red remarks on the screen. Is it a good experience?
No, sir.
No, never. But if you give that, you have encountered the same error, but you give a very polite message that something has happened to the system, please bear with us. Like there is a major fault. When you call the customer care, they say so nicely, sir, please wait us, please bear with us. Our server is down, sir. Please wait for 1 day. you will not be able to get angry with them as well. But something very minor has happened and you get so many big error message, right? You call a customer care and customer care, like instead of explaining the problem, she interacts or he interacts with very roughly with you. So for a minor issue, you get very angry with them.
Yes, sir.
That is why you always handle the exception, and always this closing of the resources you must handle within finally block. That is a must. Otherwise, your program will not pass the code checker. You must remember all these things, because just writing a code is, everyone can write a code, but you are a good coder only once you follow all the standards.
Yes, sir.
Got it?
Yes, sir.
Never do this. Never do this mistake. Never use a close within try or catch. Always do it within this. So checked exception you must handle, because you do not know what type of error it can encounter. So you do not know whether it's a like the other day we have discussed about so many types of error exception handling.
Yes, sir.
So let us, without this thing, let's run it. So what is happening here? I am saying, yeah. So it is asking me to enter a number. I say, I give a very valid number, 1, 2, 3. See, nothing is happening. I have not pressed enter. So this read line is reading. BR is reading from the read line, but it will not do anything. It will not store that 1, 2, 3 into n unless I press enter. Once I press enter, I say, yeah, it's a valid number. I say, here's the output. And what is the output? It is n, 1, 2, 3. And you have gone to the finally block, because nothing else, there is no exception. So you have gone to finally block and it is closing the resource. Fine, there is no error and the resources are closed. Just to indicate that there was no error encountered in closing this BR, I have used this just one. If there was an error encountered here, that error will be handled by throws exception, fine. And then throws exception is also going to pick up that error from the error stack trace. And that will be a long message, all in red. So what you do, and it will not come to this line at all. It will break from this point. Just to indicate that it has come to this means there was no error in here. Okay, got it?
Yes, sir.
Now,
sir, if we give the input as 1 to A, then will it show only valid integer?
Now I will do. Yeah, that was the correct entry. Always start with the true entry. Now you say A. This is an invalid entry. Okay, let's see what happens. Okay, once I pressed enter, what it did, so there it encountered an error, because it could not convert that thing into an integer, right? So yes, error lies here, not in here.
Yes. So it's just showing one line of error, only valid integer.
Yeah, because it is not taking from the error stack. What we have done is we have left it on the exception. We have left it on the exception. This is an exception, is a super exception. I do not know what type of error it has encountered. Whether it's a number format error or a null pointer exception, I do not know. So I have left it on exception. I have caught that exception. I am saying ERR means red output. Error, only valid integer input required. Only valid integer required less than equal to 9 digits. And this plus E is the pointer to that exception stack trace. So it is bringing out this message. This message is from this E. Java.lang number format. What is the exception? Number format exception. For what? For input string 123A. But see, another beauty. I have encountered an exception, but my program still continues. I have gone to finally, I have closed the resource. Yes, the resource has encountered an error, but still the resource has to be closed. Fine. I closed the resource. I had given a message. So I have encountered an exception. I still have handled it nicely, given a nice message, and I have come out gracefully from the program. Correct? Now,
Yes,
let's say I have not given, I have given this throws exception, but I have not handled it. Okay. Go step by step. I have not handled it. That means I have so I have left it on the compiler, and whatever the runtime engine throws me the error or message, I will accept it. If that is the design, that's fine. I'm not handling it. Okay, let's see. So enter a number. I give a 123A. Fine. Press enter. Now see, I am getting, for a simple error like this, I am getting so many lines of error. Why? Because this has got an exception. And one good thing you can understand that here I have still executed, though I have not handled that exception has been handled by the super exception class, and they have given me all these indicators, lines of messages, and it is saying, but still it has gone to finally block, close the buffered reader, and it has given this message. Isn't it good?
Yes, sir.
But to avoid this number of lines of exception, why I do not need to get which number, what does the user have to do with what line number of the Java code, and what is the Java code. This line number format exception has happened in that is Java 65. All these things I do not know. What is the user going to do with integer.java 580, integer.java 615? So this function is returning. This function is a integer dot function, and in this line of code 580, it has encountered this error. So all these things I have nothing to do with that. So what I will do, I will just give my own message, a very pleasant message, such that the user is not confused. What will the user do with all this message, right? Therefore, I handle this way. If you understand this, you are very well done. 123A. Now you see my.
If we remove the exception E
You
in the argument, written in the argument of catch.
Yeah.
And
yeah,
just
I am giving this, but I am not giving the output.
Okay. Then it will just only show the error message, I guess.
Yes.
Yes, sir.
Why we say E, or you can say, you can give anything.
Yes.
You can give anything. But don't give any reserved word. Okay.
Yes.
Now I see, I execute this 123A. Fine.
Yes. Also, if we don't call the variable, then it will It
except,
will
okay,
not give us any problem.
let's see.
So remove the exception written in the catch block.
I have to remove this.
I guess so. Then
So
will it
catching
give-
what?
okay. No, sir. No, sir. It will not happen.
I have to catch one exception.
Yes, sir.
Either you can say IO exception. Also, you cannot leave it. You have to give the variable. This is the format.
Yes.
You cannot change it.
Yes, sir.
You cannot change it. Okay. Yeah, here I might not use it. That's fine. But the prototype of this function cannot be violated.
Yes, sir. So catch must have any must have
But see,
the argument.
might not be an IO exception. Let's see if okay, it's a very good question. Let me run this. I have given an IO exception myself. That means I have not used the super exception. I am very sure that while trying to input an invalid number, I can get an IO exception. Let's see. I'm just trying giving us something else. Enter a number. I say 1, 2, 3, A. Now see, it has not come to this because it is not an IO exception. It is number format exception. But also, since I have used this throws exception, it is throwing an exception from this. But at least if I also do not do this, I cannot do this. Fine, I am not closing this, but let's see what happens. Okay. Okay, fine. So finally, so see the importance of finally. Even see here, I have remarked this. I have commented this out. I am not asking the user to handle it. I mean the compiler to handle it, the runtime engine to handle it. I got an error, but error has been handled by the system itself by giving all this junk thing. But at the same time, since I have a finally block, I have come to here. So I could have closed it. Yeah, I cannot close it because I will get a checked exception. I have to use throws. So they are all linked up. You are understanding?
Yes,
Everything is very much linked up. So I think we had enough of this discussion. Let us go to some user-defined exception. Oh, here also, I have an exception. I have defined my exception. What did I do? I have a user. See, till now, what we were doing, we were taking IO exception, or we were doing this exception. Okay. But did we use our exception? I have created my own class. I have created my own class of exception. I have said that I am extending the exception. So this is a super exception. I have to extend. This is called what? Extends mean?
This is the child class of my exception is the child class of exception.
And what is that process called? What is that phenomena
Inheritance.
called? Inheritance. Very good. Very, very good. So my exception is inheriting the properties and the methods of exception, and it is the super exception. So what I'm doing, I'm creating a class. So it is a class, creating a class, my exception, and the constructor is a parameterized constructor. What I am doing, I'm forcing the message that I am going to do with my exception. I'm passing it to the super. Super means exception. We have learned about super.
Yes, the super.
So,
To call the super class, we use the super word.
So I'm calling the super class and super method of that, or the whatever the constructor, and I'm passing this into this. The message I'm passing into exception. So this is what I've done. I've just defined a class. Let me use it. In this checked exception, suppose now, oh, we have a try with resource, right? Here, I say that throw new my exception. So it is creating the class, object of the class, and it is passing this message in the to the exception. So what is the exception? Here is the exception. Let's see. So I have to do a mistake, or do I need to do a mistake? Let's see. I'm not doing. I'm giving a valid number, but still, okay. Let me press enter. See, I have given a valid number, but how, you see, I have got an error. It is saying only valid integer, but I have given a valid integer. Why this happened? Why? Because I have forced. I know there is no exception. Even if there is no exception, I'm trying to force an exception. This is the wrong sort of programming, but I'm trying to show you the use. So once it encountered this exception, I mean, there is no exception. It has come to here. It is printing here's the output 1, 2, 3. But at the same time, it has encountered this line, my exception. So it is trying to execute this my exception. Where it goes? It goes here. It sees that I have to pass in the message to exception. So what will it do? It will go to exception. This exception you have got. And it is saying that, first of all, you see that it is printing in red, error, only valid integer input required. Okay. And then this EX, yes. But at the same time, it is also printing this user defined exception. So basically, it is forcing me to go to exception, though that exception has not happened. And it is also printing that message, because the exception has to print, because you have said here that I will pass in my own customized message in that exception, along with whatever exception message is there. So the entire thing is an exception message plus your user defined exception message, or whatever you say. Okay. Even if I do this, suppose now you see that this thing has changed. Suppose if I give a really an invalid number, then what happens is, are you going to, because this has encountered an error at this stage, will it go to throw my new exception? No, it will directly go to exception. It will print this, come out. After finally, it will come out, because you have given finally. If you had not given finally, fine. Let's run this again. I give an invalid message. Yeah. So I am not printing resource as a close, because I have not closed the resource at all. Okay. You're getting me? You can force it as well. Fine. So you understood how to create your own exception. You can do it. Just create a class, do whatever you want to do, that you can catch that exception. Now, let's say this is just without any condition, just arbitrarily I have thrown an exception, my own exception. But let's see when there is actually a need. We are coming to a user defined exception. When we are forcing an exception handling without actually being a compilation or runtime error. That is where we need our own defined exception. what we have done, we have given created a class. Under the main, we have say I equal to 8, j equal to 0, l equal to 10, k equal to 0. First line, I have said k is I 8 by j. J is 0. So this is a division by 0 error. Okay.
Yes, sir.
Then I say if k equal to 0, will k be 0? Because it has encountered an exception. So if it has encountered an exception, throws exception is there. So it will go to exception or my exception. Okay, first let me do this. My question is, I have encountered an error in the try block. I have encountered an error division by 0. So will it go in my exception or exception?
Exception.
Exception. Yeah, surely. Our error is, see, our error is plus E. All this thing has coming from E stack trace. It is not going to. But
Yes,
now
sir.
I'm saying that I want to make it j by I. That means 0 divided by 8. What is the result?
0.
0. So k will be 0. Is it true?
Yes.
Okay. So first of all, I will do like this. Can I do? I am forcing. I'm asking it to go to the exception, not to my exception. I can do that. Let's
Yes,
see.
sir.
Our error is Java language. So this one.
Yes.
Because actually this is not an exception. I can always get a 0. So though there is no exception, but I'm forcing a exception. So I will go to the exception handler. And my simple exception is, or you might open this and say, but you are not sure. That's why you never give a message like that. Our exception is division by 0, but actually is it a division by 0? So we should not confuse the user. But actually this I'm forcing it. It is not a division by 0. The result is 0 only, not division by 0. That's why I cannot give such error message. I leave it on the E stack trace. Let the system bring out the actual error. So the actual error is a Java lang exception, just an exception. Because it is not an error. So even if I try to print an error, there is the error stack trace is empty. So it will not give the exact error. It is just giving that I am actually handling an exception, sort of exception class. Okay, next one. Are you getting a bit of idea of exception handling? Now,
Yes, sir.
somebody will tell me what happened, what's wrong here. I will not expose the error message. Okay. First of all, let me see. Then you get a hint. I'm not getting an error here. Though I'm using the same thing, throw new my exception, throw new my exception. That means I'm forcing my user defined exception.
Yes.
What is the error? But why I'm getting an error here?
So because on this class my exception, we requested the superclass to send a message. We are sending a message to the superclass.
Okay.
And in this line, throw new my exceptions, we did not mention any line between the first braces.
So that is, you have not mentioned any arguments.
Yes.
This my function, this is a constructor. This constructor is not parameterized. Whereas
Yes.
you have you have given this my exception class a my exception constructor, which is a
A
parameter.
string message. Yes, we are passing a message, and there we did not mention any message.
So we are violating the protocol.
Yes, sir.
The protocol, the definition we are violating.
We can do it by just giving the
Just give
quotation
something like
and just space.
even if you give this, then it is
Yes,
fine.
yes, then it will also work.
Null message. Yeah, but it's still a message. So this is why I wanted to show you the difference. Why this was getting an exception and this was not getting an exception. So now I am trying to force this, though it is not a this thing, but sometimes in your application program, you might need this situation. So you must know that I can create my own exception and I will use for some condition. That means maybe that you out of the operation, your company says that you must not get a result of 0. If you somehow get a result of 0, you should throw an exception. Though it is not an exception, it's not an error, but your company business policy is saying that the result of this process cannot be 0. So
This is one kind of validation.
One kind of validation. Very good. So if you want to validate something like that, you can use an exception defined by yourself. Okay. There you are forcing a my exception with some message. Say the message is 0 is not an expected result. Okay, let's see. So these are the variation of using exceptions. Okay, so here you are coming. You are saying you are forcing my exception. Fine. So I'm coming here. You are catching my exception. You have given 2 error messages. One is 0 is not the expected result, and 0 is not an expected result. So here both of this is you are getting error and error. One, you are getting a longer error message, and the other, you see this one, you are getting a shorter message, and that message only gives you 0 is done, because this is from the E stack trace, from this. Because in the E stack trace, your error, because you are passing to the exception, right? What is your my exception? You are passing a string. So this string has to be printed, but this string has to be printed. But here you are getting only the message, and here you are getting the full message. That is the difference. That's why I have given 2 messages, so that you know. Here you are saying, so E is an output. E is one function from that E stack trace. So it's an object of the E stack trace. When I say E, you say get message. You see, get message returns the detailed message of this throwable, because you are throwing a message. So this throwable is your user defined function. Get message, and you see the returns the detailed message string of this throwable. So the function that you have, the constructor that you are passing a message to the super message, the super exception will print out. So this will be constant. This you cannot avoid because you are passing it to the exception. But here you are getting more because you are just printing everything. And here you are printing out a specific message. Correct? Are you clear with this?
Yes, sir.
So we have completed our exception handling. Any questions? Because this is one of the very, very important topics of Java core. And not only Java core, in anywhere you write anything on Java, whether it's on the web or in the sublet or this thing and that thing, you will not be able to avoid it. Any question? Jagdish, Rajshekhar, Himanshu, Deep, Aishwarya. Deep, any question? Deep?
Yes, sir. No, sir. No questions.
Are you being able to
Sir,
follow it?
this is,
Don't feel shy. Don't feel shy.
yes, sir,
Don't.
I'm following.
So you are getting it,
No, no,
got the
yes,
concept?
sir. Yes, I just want to listen. Sir, please, sir. Sir, I tell you one thing, today only for
Can
today,
you
sir, nothing else.
write down on the chat? I'm not being able to hear.
Yeah, yeah.
So, Deep, are you writing something? Yeah. Today we have not yet. You are not yet over. We have another 40 minutes. So we will start the threading, multi-threading. We will start the concept. We will complete it in the next class.
Sir, I am audible. I am audible.
Followed.
Hello.
So let us
Am I
start.
audible, sir? Am I audible?
Yeah, the voice is breaking a bit.
Okay.
If you have any question, you can write down on the chat. Or you can try to speak out. I'm not being able to hear you. That's why I'm asking you to write down if you have any question. Acha, user scanner. User scanner is one topic that is a very simple one. Like you have the buffered reader. Similarly, you have a scanner. Better to use scanner instead of buffer reader for user input, right? We have seen that if you both are resources, but this is more efficient and fast than buffer reader. And to open it, it's very simple. Like in buffer reader, you have to create an object through an input stream reader, right? So you are actually involving two resources. So there is an absolute chance that there could be some IO exceptions. But here, there is absolutely none, because you are directly, what you are doing is, you have to use the util, java.util scanner, this class. So that you are trying to enter a number, scanner, SC, new scanner. So this is a constructor of the class scanner, and this is a parameterized constructor. It is having an argument called input terminal. Scanner is advanced and much simpler to use than buffer reader. It is also easy to understand. I do not need to have another object created through input stream reader. So we can do it always you enclose within the try catch. Here we are doing it through exception. Okay. So num, you are getting next int. Here there is another very important thing. You are not converting it to a parse int. You just have to say that next int, it will convert that whatever parameter you have taken or input you have taken, that is a string, you can convert that into an integer now. And you are printing out what is your input. Exception, if there is some exception, only integer expected. Finally, in the finally block, you are closing it. Always try to close it. The scanner close. Very simple example. You must learn with the simple example, simplest examples. So enter a number, I say 1, 2, 3. Your input is 1, 2, 3. Scanner resource load. Always start with a positive expectation. Then you give a negative test. Very simple. And it's very fast as well.
So, sir, in the catch method, in the catch block, we can use system.err.println, then it will show
Then it will
in
print in
red.
red. Yes, yes. Correct. Okay. But finally, always remember that you are putting everything in a log file. In a file, you cannot have printing like this red color. Color printing is not there. So yeah, because you are using a terminal and the output screen, you can do all this color jugglery. Got it?
Yes, sir, obviously, yes, sir.
Finally, what you do, you are opening a log file or the logger, and then whatever you write on the terminal, it will be logged into that file.
Yes, sir.
Because to display something on a terminal is a costly thing, and it will reduce the performance. So never display anything on the terminal. Everything, error message, this and that, everything should go into the log file. Now, let us start multi-threading. How many of you are aware of threading? Did you use in your experience? Have you used threading? Multiple threading.
No, sir.
First time. First time.
Sorry?
First time. Sir, first time.
Yeah, Deep, you are trying to say something? Yeah, many people have worked on C, C++. So those languages you will be finding it's already there. But to use a multi-threading in C or in C++ is a bit difficult. You have to have the thorough knowledge on pointers, and you have to know how to do mutex. Mutex means you share resources. I mean, a resource, you are doing some addition, okay, by the 2 thread, or multiplication by say 4 thread. At the one point of time, all the 4 thread come to the CPU, the processor, to get the time slice. What will happen if there is no priority? Then you have to define a mutex on that object or on the method. So it's a bit difficult. Here we will see there are so many facilities given by Java. You are actually avoiding all the complexities of writing a multi-threading program. Java gives you so much of a library that you can easily use them, and your programming, your processes become multi-threading. See, multi-threading is nothing but working on multiple tasks at the same time, multitasking. Okay. One process. So we always have one main process in our Java code. So whatever you do, you must have a main method. That is the one string, one thread. Oh, I skipped try with resources. Shall we see? It is nothing but, this try with resource syntax ensures resources are closed even if try catch final block is not used. So you have one try with the buffer because you are trying to, okay, let me use this. And here we are closing everything. Okay. What I'm doing is I'm keeping n and everything I'm trying, I'm opening the buffer reader within the try block. So the try block starts here, ends here. Catch block starts here, ends here. So within the try, as if it's a function, but you are within the parenthesis, what you say, you are giving the entire thing like this. See, there is no difference. Here you have initialized the BR1, the buffer, that is, you can give BR also doesn't matter. Buffer reader BR1 equal to new buffer reader, new input string, input stream reader system.in, but within the try. So try with as if you are using a try function. This is called try with resource. That is very, very important question for interview. In this, what you are doing, you are similarly taking the read line, you are reading from the BR1 read line and passing it to an integer. Then here's the output. Resources are closed now, because here you do not have to use br.close, br1.close. By using a try function like this, you are closing everything. You see, this try with resource, you don't have to say try with resource. You just say try with resource. This one is the resource.
Yes, sir, I
Ensures,
have used it before.
yes, very important, very nice way of using it. So you do not have to declare and this and that and whatever. You do it with the try, because you are then indicating to the compiler that I want to use try directly. I want to try directly with the resource. And with this syntax, what you are ensuring is that you are, even if you don't have any finally block, but actually you are doing it with this syntax. You are closing the resource. You're opening the resource as well as closing the resource in the same time. The entire block is called try with resource block without catch or finally. I can give a catch. I might not give any catch. Till now we have learned that I can use try block either with catch or finally or both. But here we are first time using a try with resource without any catch block or finally block. Isn't it good? So it will do the try for resources. Try with resource will do everything like catching an exception and closing the resources, everything. Shall we run it?
Yes, sir.
See, it is giving an enter this thing. I have just not commented it, so fine. First of all, let's try with the positive one. So here's the output. Resources are closed. What resource closed? BR1. Okay. Now we again try it. We do 1, 2, 3, A. Okay.
Yes,
Yeah.
it will show multiple exceptions because we did not
No,
enter
exception
any.
is one. One exception is the number format exception. But there are multiple lines because it is coming from the stack trace.
Yes, sir.
But still, you are able to do it. Okay. Because you have not done this one.
Yes, sir. If we remove the if we add the catch, then it will go.
So it will be a graceful exit, or you give a soothing message. Yes, I have encountered an error. So for your information, because you have given me a wrong input, so therefore you are getting this message. But the earlier, you see the difference. The earlier message, I would get confused. What mistake did I do? Okay.
Yes, sir.
So this is, you can always use the try this thing. So what will happen if I give it both?
There is an issue. It is not entering to, in the next case. It's not entering to the first try block. Direct go to
So
the
first try,
exception.
first try is open, no?
Yes,
So
first one is right. First one is
so
first one
error,
has no
this
problem.
one it will execute
Yes,
less than 9 digits, and it is giving the entire thing for the input string. And resources are closed now. This finally,
for the finally, yes. But
because here
for
it
the
doesn't have
next
any
time,
finally. But at the
uh,
same time, error only this one is executed. Here you see IU exception. Ah, nice. You see here it has given an IU exception. Why? Because you are trying to use the buffer reader. You are opening it, but you have already closed it. In the same program, you have opened one, closed one, then trying to open one. No, it cannot happen. So there is some logical error in your program.
okay, sir.
That's why it is coming to this, because it has encountered an IO exception. It is trying to open this, and it is finding that this is already closed. I cannot do that. That's why it is giving it that your stream is closed. That's why it has encountered an IO exception, because you were trying to because you ignore this method error message, because you have given this message unknowingly. But actually the error message was IO error, not a format error, number format error. Number format exception has already been executed by this. Correct?
Hmm.
Fine. So we come to the threading. I have one thread, which is the main thread, the main process. But suppose I am trying to do a matrix. I have an array of 500 elements. And each of these elements I will try to multiply by 2. If I leave it, I have written a Java program. I have used an array of length 500, and I am trying to iterate through that array and picking up each element, and each element I'm trying to multiply by 2. Do you think it is a very simple program? Is very simple, but the processing of it, because it involves the mathematical processing unit, the arithmetic process unit, the arithmetic and logic unit. So that is a costly CPU resource, and you are expecting main to do this multiply of 500 elements with 2, and picking up every time, accessing the index, picking up that value, picking up the element, and then multiply it and store the value somewhere, some variable. Okay, so this is a costly process, and this is a resource hungry process. If you leave it on main, the process can be very slow. So what you decided, that you will have 4 threads. 4 threads or 5 threads you will spawn. You will have 5 threads helping out main. Then main becomes the mother thread. It will not do anything. It will deliver the children, the 5 children, the 5 child threads. Okay, they will be assigned to do, say, let's say you have given 100 of those multiplications will be done by each of those thread. So what is the total value? 500. So 1 to 100 will be done by T1. Then then 101 to 200 will be done by T2. So you have divided the main job, 500 array elements, into, so the array elements are one row, 500 elements, or you can say 500 columns, 500 rows and one column. Anyway, either you can view the array, but the array is a single dimensional array. You can either view it horizontally or vertically. If you view it horizontally, then how many columns are there?
Horizontally, right? One column.
No, there will be one
Horizontally
row
means-
because you are seeing horizontally.
Horizontally means.
Horizontally means
Okay.
as if it is like a tray. In a tray, you have 500
Five.
cups. Can you
Five,
invert that tray? Then all the cups will fall down. You cannot keep the tray
No, sir.
vertically.
Yes, sir.
You have to keep the tray horizontally. So when you do that, that means there is one row and 500 cups
Yes.
placed. So those 500 cups are called this thing.
Element.
Huh?
Element.
The
array
elements, 500 elements. The columns. You have organized the 500 cups to be arranged column wise. Whereas you are putting them in one row. If you see it vertically, it will be like 500 horizontal rows, but each horizontal row will have only one column. Are you sure? Because otherwise, see, if you vertically upside down the tray, the cup will fall. So you view it like there are 500 rows, horizontal rows, and one cup in each of those rows. So in total, there will be 500. Correct? Are you sure? Then, whatever it is, you have divided those processing into 5 threads, and the 5 thread will be processing either each of the row arranged in, say, the 100 rows having five cups each, or 5 rows having 100 columns. So basically, you are dividing and you are making it 5 into 100. So 5 threads handling 100 elements multiplication. So even we have 8 processors. So that is, your server is not restricted with only one CPU. There can be 8 CPUs. So if your server is powerful server, but you have not divided your main work into threads, what will happen? Only one CPU will be utilized. Your remaining 7 will be left unused. That is not a good expectation. Your program should be processor. You should involve all the processor, optimize the resources, use the resources optimally, optimize the resource use, optimally use it. So therefore, it is better if you have at least if you have 8 processors, better to have 500 array elements processed. You divide it into 5. So 5 processors will be starting to process your 100 of those elements in the same time, parallelly. So this is a thread division, and each and every thread does a work, comes back to the main and asks for the next task. Main says you have got a time. So that means the CPU will have a time slicing between each of the threads. Because after all, they are all accessing the same array. Okay. Async. Can you tell me, in this world, are the tasks, or whatever tasks there is it synchronized or unsynchronized? Like the sun and the moon, do they come up at the same time?
No,
Can
sir.
you see the sun and the moon at the same time?
No, sir.
Generally, no. Sometimes there can be exception, but generally it is no. Similarly, you will not see that there is cloud and there is rain as well as there is a sunshine. Isn't it? So they
Yes, sir.
are,
Yes.
so there sometimes can be that there is a super sunshine as well as there is heavy rain. There could be in some cases, but generally no. So we say that most of the tasks are independent. Most of the tasks, or almost all of the tasks in this world, are independent to each other. There is no link. That's why you have these microservices. Today's programming world is more towards microservices in a cloud type of environment. You build your microservices. Each of these services will be independent to each other. So one service fails, the other service will not fail. So mostly everything is asynchronous process. Okay. Asynchronous process. So when you are searching for a product in an Amazon shop, request goes to the server for searching for a product, right? If there are millions of users searching on the Amazon shop, right? Amazon.com or Amazon.in. Millions and millions of users searching for their own products. Now, think of a situation, think of a synchronized situation where unless your search, it has scattered to, all the other searches are waiting. Can this happen? The application will freeze, your app is freezing, and you are waiting for some other processing to happen. Complete. Let it be completed, then I will, then my search will be. But you do not know that already 100 and millions of users are already waiting in the queue. So if you have gone to an application like Amazon app and you are waiting for 1 hour to get your product search, will you ever use that application? No.
No, sir.
No. So every user must have their time slicing. That means every user is a separate thread. So not that only one single user is actually using Amazon shop. There are hundreds and millions. So each and every user request is a thread, is a thread. So at one point of time, there are millions of threads working on one application. Maybe it is very much possibility that you are searching for a Dell laptop and million of people, users, say 10,000 of users are at the same time searching for the same model of Dell. It can happen. So does it stop anything? Like you are waiting for something to happen, or some you are not in a queue. So this is called an asynchronous process. Asynchronous task. That means each and every thread is independent to the other thread. They are not dependent. I am not dependent. My request is not dependent on somebody else's request. Let that request be processed and then my request. No. So, but in web application, your client gives a request to the server using servlet to process the request. And just remember, after this Java code, we will start the JavaScript, and immediately after JavaScript, we will start this JSP servlet, right? So to process the request and server responds back to the client. At the same time, there are 5 clients or users who want to access the same servlet. The application will create 5 servlets to send the request. So it is also, these 5 servlets are nothing but 5 threads, multiple threads. So whether you are doing in an app, Amazon app, or you are doing it on a portal or a web application, or you are doing in a game. And in gaming, of course, there is so much of random activities. So many activities are happening at the same time in real time. Hence, it's a big area of multi-threading. So this is one area of gaming where you will see Java multi-threading is abundantly used. How do we start a thread? We say thread is a class. Thread, and I'm saying T1 is an object. I'm trying to create a thread object, T1. But this is just, you have created an object. Doing this will not automatically create multi-threading application. You have to use it. If we multiply each element of an array with 2, we need to create a class like the same class, like class myThreads, given a name. It has to extend thread. It cannot be a simple class. It needs to be a type of thread. Hence needs to extend thread. Thread is the super class for thread, multi-threading. Now I am saying I have an array with the values 5, 6, 6, 5, 1, 7, 8. So what is the length? I have restricted the length to 1, 2, 3, 4, 5. So array is values. Values is the length of values is the array of type integer of length 5. Public void run. Now this run is a method within the thread. So whenever you are implementing this thread or you are extending inheritance, you have to override the run method. That's all. That is what you do in the thread. That's all. Any thread will need to implement the run method. Like you have the main, here you have the run. If you have to do any class with thread, you must implement the run method of thread. For int I equal to 0, I less than 5, whenever you are printing the values, you are multiplying the values, each of this with 2. So think of an array where you want to organize, there are 500 array elements. So what you do, you invoke thread. How many threads? 5 threads, each handling 100 elements. That's all. So the statement thread T1 new thread now changes to thread T1 new my thread, because you are using a thread. Reference of a thread, but instantiate the object according to your threading logic. So you are using a class your thread, but you are taking a reference of thread such that you can inherit whatever is there in the thread class. Whenever you want to, so this is one thread object. So you have to start it. If you do not start a thread, this thread, whatever you have written here will not be, because whenever you say start, it basically starts to, it will call the run method. You are not needed to call run directly. You cannot say t1.run. It will not directly run like this. It has to use the thread method of start. But just need to use start, it will automatically start the run method. So methods of thread are basically run, sleep, waiting for milliseconds, wait, notify, stop, and very important is join. So let's say if my class needs to extend another class also called thread, since multiple inheritance is not supported, class A. So you know that because of multiple inheritance, what you do is you say class my thread extends A but implements runnable. Okay, runnable is an interface of thread which has a method run, same as thread. By doing so, you are indirectly extending thread. Correct? So this is, you have to remember that whatever class you are defining, it will extend another class, fine. But at the same time, because you need to make this my thread a thread class, you have to implement runnable. Otherwise, you can directly say extends thread. But since you cannot extend twice or thrice, multiple inheritance is not done. So what you do, you wanted to extend this one, this class A, but you also wanted to extend thread. So you cannot do two times. You cannot say extends A comma thread. You cannot do that. That's why you go for an implementation for runnable. Runnable is an interface, but thread implements runnable, and runnable has this run method. So thread will implement run method, and indirectly you are also implementing the run method. So whatever you are doing, you are overriding the run method. Okay. So see, you can do that. Either you do this, or in case you need to extend some other class, then you implement runnable method. This is a very important message for you. Or can you do this? Can you do this? Class my thread implements runnable. Can you do this? Yeah, you can. Are you not? Are you not understanding my question? What I'm saying is, can we have a syntax like this? So Deep says yes. Or is it Deep or somebody? What is that? Yes. Okay. Okay. Yeah. So yes, because you can always implement an interface. Why not? And run, because run is there under runnable. So you can override this run method. You can implement this run method in your own way. Can you do this? Can you do this? You must have these concepts very clear.
Sir, what was the question actually?
I'm saying I have written my class, my thread extends thread and implements runnable. Can I do this?
Just a second. My class might extend. Extend states. Okay.
Yeah.
Implements runnable.
Here you see. Where did I do? Class my
Yes,
thread.
sir. Yes, sir. I guess we can do it.
Yes, you can surely do that. What I was initially discussing was that some other class you wanted to extend. Okay, say class ABC extends ABC. Then you cannot say another comma and thread, because multiple inheritance is not allowed. Therefore, but you want to implement my thread as a thread, has a property of thread. So what you can do, you just say implements runnable, because runnable, to avoid the overcome the multiple inheritance issue. Therefore, there is a runnable interface. It is nothing but a thread. Thread is a class and runnable is an interface. But everything is same, because you are restricted here by not using more than one extends. Therefore, you can still use a runnable method, a runnable interface, and you can make this my thread as a thread. You can have this property, and you can have my thread dot start, like here. You have to make an object and then start. So if we have 80 elements in an array of an octa-core machine, octa-core means 8 CPUs. we can divide tasks into 8 threads, each for processing 10 elements. So let's say you have 80 elements to process in an array. So what you do, you divide that array into 8 arrays and process those 8 arrays by how many threads? 8 threads. So each of these thread will be automatically, the CPU knows, the computer system knows that since you have started 8 threads, so all the threads will be taken up by each of the CPUs. So each of the CPU will get one thread. Okay. And this process of allocating the threads into each of the CPU is in a logic called round robin logic. But it might not have you have A, B, C, D, E, F, G, H. A, B, C, D, E, F, G, H elements. Arrays. And you have T1, T2, T3, T4, T5, T6, each having T1 is for array A, T2 for array B, so this all the threads, 8 threads and 8 arrays. So you have to leave it on the CPU and the algorithm, that round robin algorithm. You cannot force one thread with one array to be executed into one CPU, in a particular CPU. Let's say there are 8 CPUs. So you do not say that T1 and array T1 thread to be executed by CPU 6. No, that will be determined by the CPU. I mean the system itself. The OS will determine how the spreads will be distributed among the CPUs, and the time slicing and everything will be determined by the OS. Tomorrow, or say not tomorrow, there is a function at our office. There is a puja. So we will have no class tomorrow. So Monday, we will have the final class on threading. And if possible, we will complete the file. So on Monday could be the last. Oh, no. So we will complete threading on Monday. After that, at least 2 classes will be there for, what is that? Collection. And collection is one of the most important topics, these collections.
Collection genesis.
Huh? And the last class, maybe the 3rd class, we can have devote for file IO.
1 week more, sir.
Huh?
1 week more.
Which one?
I'm saying we need 1 week extra. Upcoming we'll.
I think next week we can complete.
Yes, sir. Yes, sir.
Entire Java core we will complete. Then I will give you an assignment and all those stuff. Okay.
Okay, sir.
Very simple assignment. That's all. But I would like to see your work. Deep, tomorrow we will sit over your problem and finalize it. Okay.
Sir, we will see problem.
Hadeep, there is some audio problem from your side. So we will see. I will ping you, or you give a message on in this group. I will come to do. Fine.
Sir, may I leave? Because Sunit sir asked me to join.
Yeah, we have ended. We have completed. So, Anish, are you there?